opportunity to ask questions and interact, and we'll facilitate that. We're really lucky to have with us today Eric Young. Eric grew up on a 100-cow dairy farm in central New York. We won't hold that against him though, and has over 20 years of professional experience in nutrient management research and extension. A main research theme is evaluating agronomic and environmental practice effects on water, both overland and subsurface flows, and soil quality in cold climate agroecosystems. Prior to joining USDA ARS in 2018 as a research soil scientist, Eric was a research agronomist for 9 years at the William H. Minor Agricultural Research Institute, focusing mainly on nitrogen and phosphorus loss in tile drain systems. Eric is coming to us today from Marshfield, where he is at the ARS station there. So Eric, can you do a little bit of a mic check so I can get the sound good to go?
Sure. Good morning, everybody.
Good for everyone?
Can you hear me?
Okay, that sounds great. Go ahead.
Okay. Well, thank you very much, Amber, for the introduction and the invitation to speak today. And I'm sorry I can't be there with you in person. But that's just the way life is for me right now. So anyway, I'd like to take just a little bit of time here to describe the top picture on your right there. So this is a picture of a new low disturbance manure application equipment, piece of equipment that was recently purchased by the Fox Wolf Watershed Alliance. So some of you folks might be familiar with this group, but it's what it's showing here is a low disturbance applicator. It uses the Dietrich Shanks, and this particular unit is set up for a drag line. And so the really cool thing about this is that it can also be used in corn. So it has 30-inch row spacings, and so work at Ohio State has shown that this can work pretty well in silage corn up to about 8 inches tall. So I think that's kind of a neat opportunity, and certainly germane to what we'll be talking about here today. In the bottom picture there should look familiar to a lot of you. This is just another great trout stream in the driftless, and I believe that's the timber cooler. So field crop nutrient management. This is probably something you're all already warmed up today talking about and thinking about. So I just have one slide here to get us off on the right foot. Most of you are probably familiar with the 4R fertilization program, or right place, right source, right rate, right time, and right place, right? So these are pretty fundamental when we're talking about nutrient management and specifically manure management. And really the idea is to increase nutrient use efficiency, or the amount of nutrients that's taken up by the crop during the growing season, right? So that's good for the bottom line, and it's also good for the environment as well. And secondly, we want to focus on reducing hydrologic and atmospheric losses. And by implementing the 4R strategy, we can help achieve both of those goals. And through that, through the use of best management practices is really our opportunity to achieve greater efficiency and reduced losses, as you're well aware. So things like soil and manure testing, nutrient management and budgeting, and good old SNAP Plus, right? Erosion and runoff control, cover crops, reduced tillage, and manure incorporation injection, which we'll be talking about here today. I want to include one slide here, since we're talking about manure, just how variable it can be in terms of nutrient content. And maybe I'm preaching to the choir here, but I thought it was worth one slide just to nail the message home here. So if you look here, these data are coming from University of Wisconsin from 1998 to 2010. So it's a little bit on an age here, but I think the main point that I want to show you is just how variable the manure can be, both in solid form and liquid form. So you can see quite a wide range. If you just look at nitrogen and P2O5 here, anywhere from 1 to 125 pounds per 1,000 gallons, 1 to 170 for P2O5. So that's just a massive range. And the same type of wide variation can be seen in solid and semi-solid manures. So the take-home message here is we really want to be thinking about sampling all of our manure sources on the farm, and really ideally more than once a year. So nutrient content can change even on the same farm as the diet changes, as the forage and the bunks change, et cetera, et cetera. So sampling is really critical so we can have confidence in assigning our nutrient credits to the manure to replace that fertilizer. Okay, so as you know, there's a lot of options today when we talk about applying manure to fields, right? So we got the standard up here in the top left, the standard tried and true broadcast, right? But we also have a lot of other methods these days, such as shallow disc injection, which is a low disturbance method, which are pictured here in these two. And these are toolbars that attach to tankers, to manure tankers in general. And then here's another drag line setup here. This is another unit that's designed to be used in hay or corn. And you can hear and see in this picture here, they're side dressing some corn. Probably just about the last time they'll be able to do that, right? Without damaging it. So what I want to show you here at the top of the yellow arrows here, a lot of these methods, when we talk about low disturbance, really have the same type of physical sort of equipment in place. So in the beginning here, you can see a coulter that creates a seam in the soil, and then the next piece is the drop, is the shank, right? That in this case, it's the Dietrich shank, and then the manure is injected here with the hose after, and then following up by a aerator rolling unit. So in general, I just wanted to give you a little bit of close up for those of you who aren't familiar with this equipment, to just kind of give you a better look at what's actually going on at the soil surface. And these shanks typically go down, like with the Dietrich, is usually between 4 to 6 inches deep in the soil. Okay, so why do we care about incorporating and injecting manure? Well, there's a couple of reasons, right? One of the primary reasons is nitrogen loss, and these data are a little bit on in age as well, but I think it's good data. This is coming from Cornell University, but you can see that within about a week, of course, this is weather dependent, but on average, within a week, we're going to lose about 70% of that nitrogen that's applied via broadcast, right? So it's really nitrogen expensive not to incorporate. So even if we can use traditional tillage, that's a good thing. We can whether it's a chisel plow or disc harrow in a corn or annual situation, we can capture a lot more of that nitrogen. Okay, so what about manure application on forage crops? Well, it's pretty routine to apply manure in an annual cropping situation, right? So before we plant corn, for example, or maybe a new hay seeding. So this is pretty routine, and we can apply solid and liquid forms before we plant. And that works out pretty well. It's a little bit more challenging when we move to applying on top of forages and after hay cuttings. But again, this is pretty routine of these days. But what's not as routine is applying top dress manure, liquid manure to alfalfa stands. So this is an area that we've been looking at over the last couple years, and determining if we can use these low disturbance applicators in a alfalfa grass situation. So what are some of the advantages of utilizing manure and on forage crops? Obviously, we can reduce our fertilizer expenses, right? If we keep good track, we can build soil fertility, and not just nitrogen, phosphorus, and potassium, but also carbon, right? We're talking hearing a lot more about carbon, not only from a greenhouse gas standpoint, but also from a soil health standpoint, right? Manure and cover crops have vital carbon that becomes soil carbon and helps us maintain favorable structure and soil health too. So that's important. And also it gives farms more land to apply manure, which is always a good thing, right? So being able to apply effectively after grass cuttings and capture those nutrients, reduce runoff risk is a good thing, and we have more land available to do that. Take a little pressure off the corn ground. Some of the disadvantages, well, are there potential negative impacts on yield and quality, right? That's a big question. And of course, this is tied to many factors in the field, right? Such as application rate, method, timing, forage species, soil type, moisture, drainage, and fertility. So all these things are on the table when we talk about trying to optimize manure management on forage crops. So I'm going to describe a study that was done back in 2017 here at the research station. So I'm located in Marshfield, but we do most of our field plot work up at the Marshfield Agricultural Research Station, which is owned by the University of Wisconsin, and we co-managed it with them. And that's about 1,200 acres of land up in Stratford, Wisconsin, which is about 10 miles north of Marshfield. Yeah, so that's where this study was taking place. So our 5 treatments in this study were shallow disc injection, you're pictured here down on the left, and then an aeration banding unit. And then we just had a banding treatment alone. So that was basically this with the toolbar raised and just let the manure fall out of the drop tubes. Then we had the standard broadcast treatment, you can see here, and then a no manure control. You can see the size of our plots here, and this field was seeded down in spring 2016 with 12 pounds of alfalfa and 6 pounds of meadow fescue. Our manure application rate was 6,000 gallons per acre, and that was applied after first cutting in mid-June, and then no manure was applied after second cutting, and it was applied again after third cut in late August 2017. Okay, this particular experiment was conducted by a rainfall simulation. So this is a picture of the unit that was used, and it kind of looks like a big shower with the shower curtains there. But this allows us to have a lot of control over the runoff and where it's positioned. And so the rainfall rate we used was 1.7 inches per hour for 30 minutes, which mimics a 10-year recurrence interval storm in Stratford, Wisconsin. So that's a pretty substantial rainfall event there, as you're probably thinking. Pictured on the right here is just the setup that we use to collect the runoff and measure the runoff. And then that surface runoff was sampled for nutrient content to estimate the amount of nutrients lost. Okay, so this is kind of a busy graph, so bear with me as I try to take you through this. One of the other things that we looked at was the amount of surface coverage of each plot using digital photographs. So we were able to calculate the percent coverage of manure, bare soil, litter, and an estimate of the live plant. So all the way to the left, you can see our first rainfall runoff event. And what I really want to point out is how you can see that the broadcast and banded treatments, as well as the aerator band treatment, really had a lot more manure on the surface compared to the shallow disc injection unit. And that's pretty obvious from that graph there. Same trend a couple weeks later there for the second event as well. And so we didn't, like I said, we didn't apply manure through the second cut, so not a lot of changes going through there. But then again, manure was applied right after third cut, and you can see not as big as of an effect there as we saw after first cut. So what's the take-home point? Well, the take-home point is that the shallow disc injection really did the best job at getting the manure under the surface. And we also While dry matter yield was not measured, unfortunately, as part of the study, we didn't really see a lot of damage between the different methods compared to the control and the broadcast at the end of the day. So we felt pretty good about that. So moving to some of the water quality data here, I'm trying to be cognizant of my time here so I can leave time for questions. So across the top, we have TP or total phosphorus, TN, total nitrogen, DRP, dissolved reactive phosphorus. So that's the bioavailable form of phosphorus that we get concerned about for runoff, but it's also the form that crops take up. And then we have NH4, which is ammonium nitrogen, okay, and then nitrate nitrogen and suspended solids, or the amount of erosion in the runoff sample. So what do I want to point out here? The first thing I'd like to point out is the red box, which is contrasting the surface treatments versus the incorporated treatments. And across the board, you can see nearly everything is significantly lower for the surface, or for the incorporated, excuse me, compared to the surface. And that's not a big surprise, right? So substantially lower total phosphorus concentrations, total nitrogen, and dissolved reactive P as well. The other thing I wanted to point out on this is to take a look at the aerator band unit versus the inject. So we didn't see a lot of differences in terms of water quality parameters, with the exception of dissolved reactive phosphorus, that bioavailable form. So because that shallow inject unit did a better job of getting that manure under the surface, we think that it was able to retain more of that dissolved reactive fraction in the manure itself. Okay, so taking a quick look at economics here, and I apologize, this is a little outdated, but I just wanted to give you a kind of a sense of, the different costs between some of the equipment we're talking about. So one of the interesting things is, after the initial investment, if you take into consideration the nitrogen savings from less ammonia loss with the injection methods, that actually accounts for quite a bit of money when you take that into the budget. So the bottom graph just shows roughly US dollars per cow based on the different methods. And you can see there's really, based on this analysis, and this should be taken with a grain of salt, of course, there's not a lot of difference between the methods after the initial investment. And I should say these data come from some work out of Penn State that have looked at multiple farms using these methods, and some whole farm system modeling work that to help get at some of these ammonia loss numbers and income. Okay, so I'd like to describe, with the time I have left here, an experiment that we also did in corn silage system. So obviously the low disturbance equipment can also be used in corn settings as well. So one of the questions we had was, in a fall manure situation, something that's still fairly common in Wisconsin and other parts of the northern US, is applying liquid manure after corn silage harvest. So our question was, will we see any difference in nitrogen availability and corn yield the following spring between these different application methods, and then compare that to spring applied nitrogen. So this particular study was also conducted up in Stratford over a 4-year period, and manure was applied each fall after corn silage harvest at a rate of 8,000 gallons per acre. And you can see the treatments here that were included, and there are quite a few of them. And on the right here, I just have a picture of how, and I think most of you probably are pretty familiar with how this equipment works, and I described it earlier, so I'm not going to spend time on that. So taking a look at the average yield, so these are the grand mean yields over the study period. And these units are in megagrams per hectare, but it's pretty close to, very close to tons per acre, US tons per acre. So you can see the sweep inject had the highest yield over the 3 years. and which was not any different statistically than any of the nitrogen treatments, which went up to 200 or 180 pounds per acre. Sorry, these are in kilograms per hectare now, which is about 180 pounds per acre of nitrogen. So actually the highest yield was overall was with the sweep inject. So that we found that pretty interesting. And so the bottom line is that with fall applied manure may not be the best in every situation, but if we can capture more of that ammonia N by getting it into the soil, it appears that some of that nitrogen is still available the following year for the corn. So that's good news. We also looked at soil nitrate at different depths in this study, both in the spring and the fall. And I know there's kind of a lot going on here, but I just want to point out some of the general trends. You can see that the sweep inject and the strip till inject both did quite well at retaining nitrogen. So in the spring, we still had over 30 parts per million of soil nitrate. And for those of you who utilize the PSNT test, you know that 25 is right around that critical point. So that's a good amount of nitrogen hanging out there in the soil profile. And also another thing to note here is we didn't see a lot of leaching. So if we go down to 30 to 60 centimeters and then 60 to 90, you see that nitrogen kind of tail right off, which is a good thing, telling us that we didn't see a lot of nitrogen leaching under these conditions. And then in the fall, somewhat similar trends again with the sweep inject and the strip till injects standing out in terms of nitrogen retention. Okay, so a little summarization slide here of the corn silage study. So as I said, the LDMI treatments had similar corn yields to the highest spring fertilizer N rate. There's no difference. The low disturbance equipment is much more compatible with a cover crop. Does much less disturbance, so that's a good thing going into the winter. And then we also saw an increase, statistically actually significant increase in soil organic carbon and aggregate stability with the strip till inject. Okay, so just wrapping up here, we've also been looking at low disturbance manure incorporation and its impact on greenhouse gases. So here, pictured here is just nitrous oxide. And on the top is just temperature and moisture over the season. And this is in 2016, and the bottom is N2O. And this is in units of grams per hectare per day. And you can kind of see these spikes that we catch. And they're definitely driven by changes in moisture. So if you know anything about nitrous oxide, you have available nitrogen in the soil, and you have a rainfall event, you get the reduction of that nitrate by the soil microbes under sufficient conditions, and then we get these spikes of N2O release. So if you take a look at the cumulative N2O losses over the study, you can see that obviously control had the lowest there, the black bar, but then the shallow inject and aerator band had higher amounts of N2O, and that's because they retained more of that available nitrogen. So kind of a trade-off there, good for nitrogen fertility, but it did release a little bit more of that N2O. Okay, and with that,